Okay, good morning, everybody. So let's get started. So I wanted to start today's discussion with the concept that I felt I did not explain, very well in the last class, the network ACL. So I took more time to kind of prepare the whole presentation for that. I wanted to make it absolute clear. So let's talk about it. Network ACLs. So what is network ACL? Well, network ACL is an optional layer of security for your VPC that acts as a firewall for controlling traffic at subnet level. It is like security group, but security group is at the instance level and network access control list is at the subnet level. So it stops you at the front door itself. So if you deny certain IPs, you'll be able to do it using NACL, Network Access Control List. And the traffic doesn't even come into the instance or security group level. Your security group level rules will be evaluated right before your instance. Okay, but the network access control list will be evaluated before the packet enters into the subnet. I want you to understand that. So this is at the subnet level. Okay. So when you create a new VPC, a default NACL is created. So when you create a VPC, automatically it gets created. And by default, it allows all inbound and outbound IPv4 traffic, and if applicable, IPv6 traffic. It allows both of them by default when you create a new VPC, because this is an optional and additional layer of security at the subnet level. But it's a very good tool for security. So the second point is applicable when you create a VPC. The default NACL that gets created will allow by default all inbound, all outbound. But when you create a NACL by yourself, okay, at that time, by default, all the traffic is denied. So let's take a look at this third point. You can create a new NACL and associate it with a subnet. By default, a new NACL denies all traffic. When you create a new network access control list by yourself, it denies everything. Inbound deny, outbound deny. You have to put the rules explicitly. Each subnet must be associated with a NACL. So each subnet must be associated. So there is no exception to that. You cannot have a subnet without having a NACL association. So if you don't specify, the default NACL will be associated. Yes. Does it make sense? So, and each subnet will only have one and only one NACL be associated. But that NACL can be associated with multiple subnets though. I want you to understand that. You can associate a NACL with multiple subnets, but each subnet can be associated with one NACL at a time. If you want to change it, well, you need to replace it. You can't have two NACLs for one subnet. Does it make sense? These points so far?
Last one, can you please reiterate for this?
Absolutely. So each subnet must have a NACL. One NACL and only one. Does it make sense?
Yes.
Now, when you create a NACL is nothing but, it's a network access control list, nothing but a logical entity that has rules for inbound and outbound, like security groups. And once you create that, you can go attach to as many subnets as possible.
Yep, got it now. Venkat,
Yes.
if we go back on the previous slide and the second point,
Yep.
like when you create a VPC, default NACL will be created, right?
Yep.
At that point, it would be associated with both the subnet by default, or?
So when you create a new VPC, when you sign up, okay, when you create a new custom VPC, do subnets get created?
No.
Exactly. So at this point, subnets will not be created. When you create a new VPC, your new VPC will be created, your route table get created, and then your NACL will be created. Now, when you create, remember we created two subnets, one public subnet, one
Yep.
private subnet,
Mm-hmm.
automatically, but we never touched NACL though. We never touched NACL because it automatically gets associated to the default NACL.
Ah.
So when
So
you,
both the subnet would automatically associated with the default NACL
you got it,
without.
you got
Okay,
it,
that's what I want to make sure. Both of them.
you got it, you got it.
Yes. Okay. Okay.
Actually, since maybe everybody may have the same doubt, right? So why not do that? So we can verify that in 1 second. So I only have a default VPC. So let me go ahead and create a VPC. I'll call custom VPC. So at this point, my network ACL, if you look at it, so this is my new one. See this one? This is a new NACL that got created automatically because I created a new VPC. And look at the inbound rules.
Everything allowed than that, right? 100, 200, and then second one is the
Am I? Oh, oh, I'm sorry. Yeah. So this is the default NACL that got created when you create VPC, right? See here, when you create a new VPC, a default NACL is created. By default, it allows all inbound and outbound IPv4 traffic. So yes, it is allowing all inbound and all outbound. Okay.
Yep.
So this is your default NACL. Let's go ahead and create a new NACL. Now, and then within the custom VPC, now I'm
In
creating
that,
a
everything
new,
would be blocked, right?
now I'm creating a new NACL. Now take a look at inbound rules, all deny, outbound rules, all deny. Make sense, guys? So this is what I mean. Now, if you go to subnet, actually take a look at this one here. For this custom VPC, it is saying the default is yes, the previously created one, and what we just created says default no. So what happens is when I go ahead and create a new subnet, create a subnet, let's say public subnet, the custom VPC. I'll pick AZ1. So new subnet got created. This is my public subnet. Take a look at network access control list. So it is associated with this guy, 285B762. Let's go open it in a new, this one. And that's your 5B762. See this one? So that's your default NACL, which allows all of them. So see this one? All allow and outbound all allow. But you can change the association, edit network ACL association. You can change it to your my new NACL, which denies everything. Make sense?
Yes, yes, Venkat. Now it's very clear now. Thank you.
Wonderful. Network ACL is an option. Oh, we're done there. Okay. Network ACL contains a numbered list of rules. Okay, 100, 200, 300, like that. The rules are evaluated starting from lowest numbered rule to determine whether traffic is allowed in or out of subnet associated with an NACL. So when I evaluate it, when I get the packet, I will evaluate it. Okay, are you trying to reach this subnet or an instance within a subnet on port 80? Okay, let me see if you're allowed. So let's say rule number 100 is allowed It doesn't even go into the rule number 200 or rule number 101. It doesn't even go there, because my first rule that says that it's allowed, so I'm good. Or if the first rule says that it's denied, it's denied. It doesn't even go into the next one. So that's why.
So Venkat, when designing, we have to be careful, right? The order.
You got it. Yes, Murali. So if you want to explicitly deny them, your deny rules must be before the allow rules. Very important point. And both for the exam and also for the real life. A network ACL has separate inbound and outbound rules, and each rule can either allow or deny traffic. This is an additional difference between security group and network ACL. In security groups, you only have allow rules. You cannot deny. If you want to explicitly deny traffic from a specific IP address, you must use network ACL. And another important difference between network ACL and security group is that network ACLs are stateless. Means that, so when someone out from internet is trying to access my web server within a subnet, okay, on port 80, so you have to have a port 80 must be allowed in, and whatever the response, let's say the client has opened his port on particular port, some port number. So you have to allow the outbound traffic. So when a packet request coming in does not guarantee that response will be written out as well. But security group, when a packet comes in, it will make sure that it goes out. But that is not the case with the network ACL. You have to define the rules: packet coming in and packet going out, request coming in and response going out. Or instance is trying to go out. Let's say instance is trying to do a sudo yum update. So it's making a HTTP call out to get some software or to get some packets in. So request is going out from subnet and the response has to come in too. It has to be allowed. So it's important. It is stateless. So you have to define both the rules, guys. Before I go to the rules, does it make sense? Okay, let me see. NACL rules. These are evaluated from lowest numbered rule to highest. As soon as a rule matches traffic, it's applied regardless of any higher numbered rule that might contradict it. So if rule 100 says allow, but rule 120 says deny, it gets allowed. It doesn't even go to 120. Each network ACL also includes a rule whose rule number is an asterisk. You saw that star there, right? I know you'll not be able to edit that. You saw that star. By default, this means that if, let's say you have 10 rules above, if all the 10 rules, if traffic doesn't match all those 10 rules, it will get defaulted to this one, which means by default it's denied. Okay. So each NACL also includes a rule whose rule number is an asterisk. This rule ensures that if a packet doesn't match any of the other numbered rules, it's denied. You can't modify or remove this rule. Does it make sense? So let's go ahead and take a look at an example. Let's say you wanted to deny an incoming traffic from a specific IP address. That's the IP address, 16.32.167.4. I want to deny. You added a new rule number 110 to deny the traffic from that IP. So let's say in your NACL, there was already a rule number 100 already exists. So let's say this is how it looks. Your rule number 100 says that HTTP traffic, port number 80, port is just 80. This is HTTP, TCP. So allow it to all the IPs. O.O.O.O/O means everyone in the world. So everyone is allowed on port 80 for the inbound rule. Okay. But your 100 and rule number 110 says that deny for this specific IP. Will the traffic be denied? Will the inbound be denied here in this use case?
No, Venkat. We need 100. Yep, we need other way around.
Exactly, because 100 allows it and it doesn't even go to 110. Will traffic be denied? Nope. Since rule 100 says allow all traffic on port 80, rule 110 will be ignored. The rule number should have been below 100. Yes, you should have 90 or 99. This deny rule must be before rule number 100. So understand this, and you will likely get 1 or 2 points in the exam also. And it's a very important security aspect in real life. Okay, now let's talk about something called ephemeral ports. Is everything clear so far? Okay.
Yes, Venkat.
So let's talk about this ephemeral port. So let's say you have a user who is using some Windows laptop. He is making a HTTP request to a web server that you built. This web server is building on is listening on port 80. So this laptop. So whenever we say that the port 80 is open, port 80 should be open on the inbound, or port 80 should be open on the outbound. Every time we talk about it, right? So we are not talking about the client's port, guys. So we're only talking about the server port here. So, but what this client does is they will send the request to port 80 on this web server on a completely different port. So in this example, I put the port number as 50,000 for this laptop device. So there is a range of ports for each computer based on your OS and other aspects. Okay, there's a range of port range that's called ephemeral ports. Ephemeral meaning it's short-lived. So it uses that particular port just to send the packet to the web server and listen. It will continue to listen on that particular port to receive the response back. Once the response is received, then that port will be closed. The listening will be closed. And then the next next request could be going on a different port. Does it make sense? The next request could be making from a different port to again port 80, but when you write the response back, you have to write to that port. So that is why on your side and here, when you give the response back to the client, you have to have those ports open. Request coming in will come on port 80 only, but the response will be returned to whatever client is expecting. So that's why you have to have those ports open on your outbound rule. Otherwise, your web server will not work. You will get the packet, but the packet will never go to client. The response will never go to client. So that's why it's both inbound and outbound. So in this example, web server is listening on port 80. It's called a destination port. So your source port is 50,000 in this example, but it can be anything. And your destination port is port 80, your web server. Every client uses a different ephemeral port to send the request. Not only, it's actually not a different ephemeral port, it's a port range. Okay. Your Linux has a certain port range and your Windows has certain port range. Windows 10 until XP, I believe they have a different port range. Now it's a different port range. expects the response back on the same port. So when I make a request on port 50,000, then I expect the response back on the same port. That is why that 50,000 port must be open on this one. Ephemeral ports are short-lived. After the response is received, port will be closed on client machine. For the next request, the client port could be a completely different. So we need to open the port range. That's why we don't know. And this is again Windows machine. Maybe someone is using Linux machine, that port range. We need to find out the port ranges across all of our clients. And then we need to open it on the outbound. On the inbound, we'll open only port 80 for the web server scenario. Does that make sense? I'll pause here for a second and see if if it makes sense or not. I'm going to take an example here. Take a look at this one. So I have a web server and I want to allow the traffic on port 80 because it's a web server. So I have a rule number 100 here, HTTP, port range is 80. So I'm allowing traffic on port 80 to everybody in the world. Of course, this asterisk is a default one that's there always. Of course, it never gets executed in this case because port 80 is allowed to everybody, right? Let's say when the request is coming, when someone is trying on 443, will traffic be allowed? No, they will go to this second rule, asterisk rule. Anyways, my point is, I have a web server running on port 80 and I wanted to allow traffic on port 80. This is how the inbound rule looks like. It's very straightforward, understood. So the packet is in the packet arrived into subnet, and eventually it went past the security group and into your instance. Now your web server respond back. When web server responded back, the corresponding port range must be open for clients to receive. Otherwise, client will never receive the packet. So your outbound rules look like, for this to work, your outbound rule looks like your rule number, custom TCP rule. So I gave this 32,768 to 61,000. This is a port range. This is a common, port range, mainly for including the Linux devices. This works for both Linux and new Windows machines. Okay. So if it's a Windows XP, I believe it starts from 1000 itself. So they changed it to start from 50,000, starting from Windows 2003 server or something like that. But anyways, this port range is different for different client machines, is what I wanted to say. But this typically works for almost everybody. You can safely put it, allow it. This is an ephemeral port range. But if you think that, if you identify that one of these ports or some of these ports are malicious ports and you want to block them, you can do that. But you have to put those deny rules before 100 so that it will be denied. But generally, this ephemeral port range is to write the packet back or to send the response back to the client machine. Does it make sense? And by the way, so I opened port 80 for incoming traffic. I did not open port 80 on the outbound side. Does it work?
It should.
Absolutely. It will, because port 80 is for the web server on the server side. But in this example, the previous example we've seen here, right? Port 80 on the destination port, but the source port is 50,000 here. So we took care of the source port here with the port range. So this is how your configuration must be. If you have a 443, again, You put an inbound rule here for 443 and your outbound rule. This works. But tell me, that web server is trying to do some patches, sudo yum update. What happens at the time? That web server in that subnet is trying to do a sudo yum update.
It is not going to work, right? It's 443 port at that time, right?
It will not work because the outbound rule, what is it trying to do? It is trying to make a HTTP call to some website and try to get the updates. It's trying to make a HTTP call, either port 80 and 443. It's trying to do that, right? But port 80 or 443 are not allowed on the outbound side. So if packet needs to go out from the subnet, then you need to open the corresponding rule. Again, the packet will go out, but the packet has to come back to the subnet, right? At that time, you have to open your ephemeral ports because yours is a Linux machine too. Does it make sense, guys? You have to be able to take the packet back. So before I talk about the differences between security group and network ACL, any questions here? Is it clear?
Yes,
Okay.
okay.
Okay. So let's take a look at the differences between security group and network ACL. Security group operates at the instance level. Okay. So when you create every single EC2 instance, you will attach a security group. You create a logical, rules and create a security group. You can associate that security group to several EC2 instance. Okay. So, but that's at the instance level. But NACL, network ACL, is at the subnet level. So when you put the rule out, all the EC2 instances within that subnet will have the same effect. So security group supports only allow rules, and NACL allows both allow and deny rules. Security group is stateful, meaning when a packet comes in, the response will be automatically allowed. But that's not the case with NACL. You have to open up exclusively both inbound and outbound traffic. All rules are evaluated before deciding whether to allow traffic or not in a security group. Here, rules are evaluated based on the number, and then once it hits, either allow or deny. Once it hits, it doesn't go to the next number. Security group applies to an instance only if someone specifies the security group when launching the instance or associate the security group. So it's at the instance level, essentially. This one, network ACL, automatically applies to all instances in the subnets.
Hey, Venkat, one quick question here.
Mm-hmm.
So, security groups are at instance level, but network is at subnet level, right? So
Mm-hmm.
that's how it works.
Mm-hmm.
But if you can you control or can you overwrite network ACL using security group on an instance level? You can give the network ACL can be open, but can you restrict it security group level?
Absolutely.
Does it make sense? Yeah.
Absolutely. Oh yeah. Let's take a look at how does packet travel? That's a good question and good segue to this one. So let's say you are outside somewhere here, client. So you are trying to access the web server somewhere in this, in this subnet. Okay. So traffic comes to internet gateway or through virtual private gateway if you don't have internet connection. But let's say in this example, it's coming through internet gateway, and your router takes it and then your route table gets evaluated. Okay, to see if there is a route or not to your subnet. And then your network ACL sit here. So the network ACL these guard the entire subnet here. So whether the packet will go into the subnet or not will be evaluated by the network ACL rules. But let's say the packet went in. So now packet went into the subnet. Here, does it reach the instance or not is evaluated by your security group rules. Your maybe NACL allows it. Your network ACL may allow it, but security group could safely deny it. That is an incoming packet from outside. So when a packet is coming in, when a request is coming in, your network ACL rules will be evaluated before the packet hits the subnet. After that, your security group rules will be evaluated to see if your instance, if packet reaches the instance or not. But now, on the way out, let's say, when I make a request here, I'm inside this web server. I'm logged into the web server. I did a sudo yum update. Okay, or I'm trying to install HTTPD. Sudo yum install HTTPD. I'm trying to do this one. Now the packet will go out. Your security group will come first. When the traffic is going out, your security group will come first. Your NACL will not come into picture yet, because first your security group must allow it, and then your NACL should allow. Your NACL's outbound rule will come into picture. Okay, and then if NACL allows it, then it will go out to the either through internet gateway or virtual private gateway, and then it goes out. Of course, if the route exists. Does it make sense? Packet coming in from outside and packet going out from inside.
So, okay, I have one more question here, Venkat.
Absolutely.
So you have two different subnets, exactly how you're showing in your figure right now, in your diagram.
Yep.
By restricting on from NACL level, but can I still make sure that the instances on two subnets can communicate together?
I will restrict at the NACL level. Okay.
So because just consider this as one is in DMZ and one is in local network within AWS.
One is in, okay. Yeah, public and private subnets.
Public and private subnets, right?
Yep.
So you have two different security groups maintaining on instances. Just say, for example, I want my production environment very restricted, secured, but I still want to ensure that my development quality have that,
Mhm.
a little bit of, a
Yeah.
luxury or
Mhm.
say whatever it is, but still I want them to communicate together, but they are entirely two different security groups, entirely in two different network ACLs.
Yep.
But I still want to ensure that they communicate each other. My production and my quality are communicating each other.
Are they in two different subnets?
Mostly it will be in same subnet, but sometimes if it's a cross applications, yes, they might be in a different subnets.
Yeah. If they are in two different subnets, then again your network ACLs come into picture, right? When you make when packet goes out, understood, within the same VPC, but when a packet goes out here, when a request goes out here, your NACL will come into picture, evaluate it, and then there must be a route out. And at this route level, you have a route. Every guy within a VPC can talk to each other, but you can restrict it at the NACL level. Whether this instance can talk to this or not, who defines that? Well, you can define at the security group level whether you want to allow or not your CIDR block, and then you can do it at the NACL level itself. You can define in such a way that nope, you can talk to these guys. Does it make sense? Or are you asking completely different?
No, it makes sense, but again, so my question is like, for example, so let's talk in an on-premise. Let's say that whole VPC is a data center for us.
Mm-hmm.
We have two different zones again, right? Within the data center, we'll have a DMZ and we'll also have an internal local network.
Can you hold there? Can you pause for a
Okay.
second?
Sure, sure.
So you have your DMZ. That's where your internet traffic will be. All the servers that take the internet traffic will be in your DMZ. Okay, that's one subnet, and all of your backend servers are in a different subnet. That's a typical setup, right?
Correct.
Okay, yeah. So understand that we have two different subnets, and let's call them as public and private itself, since everybody is familiar with that. So we have a public subnet, that's your DMZ, that's more prone to attacks from internet. Okay, and you have your private backend servers. Okay, now let's talk. First of all, did I understand that correctly? So we
Oh,
have two different.
absolutely. No, you're absolutely coming looking for. Thank you, Venkat. Yeah.
Oh, no. I thought we are still describing the problem itself. I'm just, making it clear so that everybody can understand. We have two different subnets, public and private. Okay.
And Venkat, is it? I'm
Okay.
just making sure. Is it in the same VPC or it's in different VPC?
It's in the same VPC.
If it is in the same VPC, doesn't it automatically talk? So private and public can connect without even a internet, right?
At the router level,
Yeah.
at the router level, by default, your route table allows the traffic, every instance will be able to talk to every instance, meaning every instance will have a route to the other instance within the VPC at the router level, at the route table. Okay.
Yeah. Mm-hmm.
If you look at the route table, that's what you will see, a local route table there. Okay. But it does not mean that automatically gets allowed. You have a right in front of subnet, you have a police here. You have your network ACL. Packet going out will be evaluated by the outbound rules. Packet coming in will be evaluated by the inbound rules here. Doesn't matter, even within the same VPC.
Yep, got it.
Okay, that's one scenario. Now let's talk about, you have both the backend servers here. Okay, let's say it's a database server, and this is a, let's say, Tomcat server, and these are, let's say, web servers, HTTP servers. So these are both the backend servers. These guys can talk to each other. Your network ACLs will not come into picture because these are in the same subnet. Now these are applicable only through the security group. Make sense? Your network ACL rules will not come into picture at that time.
But if I have to talk to that web servers, then definitely it should go through network ACL definitely, without any question.
Absolutely.
Okay, I got it clear. I mean, I'm just trying to compare. So let's see. I mean, how exactly it works, because most of the servers. So in this case, we have two different subnets. I mean, many subnets, but anything within internet facing should be more open. I mean, when I say, yeah.
Exactly. So whoever can potentially take the internet, they will be in DMZ. Okay, that's where you have to be very careful. You are prone to your DDoS attacks and other attacks. Okay, because you have to be in, unfortunately, you have to be in that zone. And but you'll be able to put all of your backend servers in a separate subnet, and you can put them as restricted as possible. Okay, so that's it, guys, about NACL. Do you want me to show you an example?
Yes, please.
Okay. So let me see if I have an EC2 instance here. Okay, I have an EC2 instance here. And by the way, to do all of this one, you don't need to create a brand new VPC. I mean, it's a good idea to create as many VPCs as possible so that you will understand the concepts so deeply. But when you create your account, you will get your default VPC. You can play with those default knuckles. You can create new ACLs. You can attach to subnets and all. You can do all of that. I just wanted to let you guys know. So I have this web server, and this is my public DNS. And let me go. Hello from EC2. I don't need to tell you how I did that. I already have it. Okay, in this example, let's take a look at it. This is in what VPC? This is in my the default VPC. See this one? This is my VPC ID. This is the default VPC. And where is my subnet? This is my subnet. Let's go to subnet. So what's the ID of the subnet? 2BC9. 2BC9. This is, let's call it, what is this availability zone? US East 2B. So US East 2B is availability zone, and then let's name this guy as US East 2B subnet. So my EC2 instance is in this subnet, guys. Okay, US East 2B subnet. And by default, when I created this account, it automatically created a new VPC, and it automatically created three subnets, one in each availability zone, one in 2A, one in 2B, the other one is 2C. So when I created this EC2 instance, I created this in this 2B subnet. Okay. Are we clear so far? And now let's go to network ACL. So for this subnet, US East 2B subnet, let's go to network ACL. By default, the network ACL says that allow all the traffic because this is a default NACL. Okay, this is the default NACL. So let's go to network ACLs, and 0823 is the NACL ID 0823. So let's rename this one to default NACL to default NACL to default VPC. Okay. And this one, the above one is, we just created custom VPC, right? That's a default NACL to custom VPC. The above one here. This is default NACL to custom VPC. Okay. So this is my default NACL to default VPC, and let's go take a look at the rules. Inbound rules, all allow, and outbound rules, all allow. So that is why I'm able to talk to EC2 instance within this 2B availability zone. Make sense? Now, I have two options. Now I want to restrict it. I want to restrict it only whatever makes sense based on my use case. What is my use case? I have a web server and I want to allow the traffic only for that port 80, and I want to restrict everything else. That's my goal. So I have two options. I can go change this default NACL, or I can create a brand new ACL, apply the rules there, and then I can associate that ACL to my 2B subnet. Make sense? So let's go ahead and create a new NACL. Custom, you know what? Let's put WebDMZ NACL. WebDMZ NACL to default VPC. So I'll create, in the default VPC, I'm creating that NACL. Okay. Now, let's go take to WebDMZ NACL. So by default, everything is denied. Let's go change the inbound rules. So inbound, I'll add rule number 100. So it's a good idea to do these rule numbers like 100, 110, or 200, something like that, so that you'll be able to insert the rules in between. Rule number 100, and I want to allow HTTP traffic, port 80 to everybody. So everyone must be able to talk to me, talk to the subnet on port 80. Okay, everybody can come in, but now I have to go, the packet needs to go out, right? So this is where I'll put the outbound rules. Again, rule number 100, and this is where I have to put the custom TCP rule and my port range, whatever the port range that I provided there. $32,768 all the way till 61,000. Okay, and allow this. Whatever we just, I just showed it to you in PowerPoint. I'm just doing it. WebDMZ NACL. I have this guy. Now, how do I do that? Now I'll go to subnet association and then edit subnet associations. And we have this US East 2B, right? This is where my web server is. I'm selecting this guy and editing it. Now my US East 2B subnet is associated with my US East 2B subnet is associated with the WebDMZ NACL that allows port 80 on the inbound side and ephemeral port range on the outbound side, so that I'll be able to give the response back to wherever it was originated from, whatever the client port is. Now let's go verify that. Yes, it's still working. So now what we'll do is, let's go change our, let's go to our network ACLs, and then let's go to our WebDMZ NACL, and let's allow the port 80, and on the outbound rule, what I will say is, let's say rule number 110, what is my IP? This is my IP at this time. Sorry. /32 since just mine. So I want to, this is outbound. I want to go back to the inbound rules. And then now I want to add a new rule to deny, please deny the request from my IP on port 80. So what happens now? I'm denying port 80 to my IP. Will it be denied? Take a look at this one. You'll get this in the exam. Will it be denied now?
No.
No.
Because of 110, right? 100 is to allow everybody. So if I change this number to 90, for example, will it be denied now?
Yes.
Yes. Take a look at that within a second. Just these, when you change the rules, they get applied immediately. Whether the security group changes or your NACL changes. See that? It's spinning because it will not be allowed. Your rule number 90 came into picture. Now, what you can experiment is that, yep, so I got the error and now I'll change it back to, but you can try the public IP of this one and you should be able to allow it. And we saw that. So that's not a big deal. So now take a look at it. Yep, now it got back. See that? So within the same millisecond. And in the outbound rules, let's say that if I didn't know about this ephemeral port range. So let's give, okay, I thought that I got the request on port 80. I mean, I'm listening on port 80. So I got the request on port 80 and I will write back on the port 80. So I assume that client is also listening on port 80. That's wrong. Okay. Our understanding is wrong. And the outbound rule, I have port 80. Now take a look at it. It will spin forever because you'll not be able to. Your request went into the subnet. It went in all the way to your web server, and web server gave back. Your web server gave back the response, but it's not going out of your subnet. It's because the request was sent on my laptop from a different port. This is a Windows 10 laptop, okay? And then I didn't open that port. So that's why I need to open that port range. This is outbound rules, and it's a custom TCP rule. Once I give the port range, then it will automatically, magically, yep, there you go. Makes sense? So this is what I wanted to clarify to everybody. And then I gave the homework also exactly like this. And I wanted you to kind of appreciate all the topics that we talked about. I'll share this PowerPoint also. Any questions so far?
Very clear, Anand.
Yeah,
Hari,
very,
thank
very, you are right with that. Very nice.
Yeah, I was not happy with so I felt that was not to my level. So it's like I just like you know what, let's create some PowerPoint and let's go deep dive and then make it absolutely clear. And it's important from the exam perspective too, and it's real life too. So you will expect this kind of questions, guys. Okay. So what I will do is I will probably stop the recording here so that it's a separate concept.
Hey, Venkat.